Alright guys, so we're going to talk about how to write a balanced equation from words. And that was our essential question. How do I write a balanced equation from words? And there are a couple of things that you're going to need to know about in order to do this. The first is, so let's do rules for writing word equations. Rule number 1. When I'm reading a problem and it says something like sodium metal reacts with, or magnesium metal is added to, when I have a metal by itself, you're just going to write the symbol for that metal. Okay? So when I'm talking about a reaction involving sodium, when I go to write that in my equation, sodium is just going to be Na. Okay? Now if it says something like sodium nitrate or sodium phosphate, that's not sodium by itself. Okay? That's sodium with something else. But if it just says sodium metal or magnesium metal or copper metal or whatever, if it's just that by itself, you just write the symbol for it. So that's one of the rules. Rule number 2. A nonmetal by itself you need to check your diatomics. Let me explain what a diatomic is. First of all, the prefix di we know means two, and then atom, so two atoms. Okay? So in other words, it's an atom that cannot exist all by itself. And there are several different ones. There are 7 of them actually. There are several different nonmetals that cannot exist by themselves. They're too electrically unstable to be all by themselves. So let me show you who they are. So grab your periodic table and look at this with me real quick. Okay, there are 7 elements that are always going to be diatomic whenever they're in a compound. One of them is hydrogen. So hydrogen is always going to be H2. Nitrogen is always N2. Oxygen is O2. Fluorine is F2. Chlorine is Cl2. Bromine is Br2. And iodine is I2. Now check it out. Do you guys see the number? 1, 2, 2, 2, 2, 2, 2, 2, 2, 2, 2. See the number 7 right there in the corner of your periodic table? There are 1, 2, 3, 4, 5, 6, 7 elements that are diatomic. I call them the 7 that make a 7 because they actually make a 7 on your periodic table. Okay, so they are the 7 that make a 7. Another way to remember this is Hofbrinkel. Hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. Okay, so whichever way makes the most sense to you, the 7 that make a 7 or Hofbrinkel. So those ones, when you see it say chlorine gas reacts with, so I automatically need to know that this is Cl2. Okay, hydrogen gas is produced, H2. You're never going to see those guys by themselves. And then the third rule is for all compounds, you're going to use your nomenclature rules. Your flowchart that we made in class, page 9 of your notebook, and then also page 17 for the acids. Okay, so page 17 is the acids. Page 9 is all other compounds. Okay, so those are going to be the way that we do that. And this is something that you guys have been struggling with a lot, and so we're going to practice this a lot. All right? Now, the harder part of this is reading the question and figuring out which ones are going to be the reactants, which ones are going to be the products, where the arrow is going to go. So let me give you some guidelines for that. If you see reacts with and, it's not and, Miss Crane, and is mixed with anything of that nature. This is where a plus goes. Okay? This reacts with this. So you put a plus between this and this. Okay? If you see reacts to form, produces, or yields, this is where your arrow goes in the equation. So, those are some just basic guidelines for how to do this. You might want to grab a couple of different colors of pen and maybe even a highlighter, and we're going to do some problems together. Alright, so this is an example of the kind of problem we would see. Solid zinc metal reacts with lead-2 nitrate to produce zinc nitrate and solid lead metal. So let's start with just the symbols we need. Alright, I've got a reacts with here, and that means reacts with, that we said was going to be a plus symbol. So let's underline reacts with and put a plus there. I've got an and between two things. I've got zinc nitrate and solid lead metal, so the and is also a plus. Alright, I've got the word to produce, and remember we said to produce is where the arrow goes. Okay, so this plus this yields this plus this. Alright, so now I'm going to take my green and I'm going to circle my reactants. So the things that come before the arrow. We have zinc and we have lead-2 nitrate. Those are before the arrow. And then after the arrow I have zinc nitrate and lead. Okay, so to write this equation I need zinc metal. So let's go back to our rules. Rule number 1 was that a metal by itself, we're just going to write the symbol. This is solid zinc metal. It's not zinc chloride or anything like that. It's just zinc metal. So I'm going to write just the symbol for zinc. They've told me it's a solid, so I'm going to put a parentheses and a little S next to it. And then I have a plus, so I'm going to put my plus in. Now then I have lead-2 nitrate. This doesn't fall under any of those three categories. It's not a metal by itself. It's not a non-metal by itself. So this is rule 3, where we need our nomenclature rules. So I'm going to crisscross my charges on lead-2 nitrate. So lead, they told me right here, has a +2 charge. Nitrate, ATE, means it's a polyatomic ions. So let's find our polyatomic ions chart. Nitrate is NO3, and it has a 1- charge. Lead is PB, remember the peanut butter, lead, the jelly, and they told us with this Roman numeral right here that it's a 2+ charge. So when I crisscross my charges, I'm going to take the 2 from lead, and I'm going to put it over here. Oops, that's not a 2, Miss Crane. Sorry, guys. I'm going to take the 2 from lead, and I'm going to put it over here. I'm going to take the 1 from nitrate, and I'm going to put it here, but remember, I don't write ones. So we're going to leave it like that. So this is just going to be PB parentheses NO3 parentheses 2. Then the next thing that comes in my word equation is the blue arrow. So I'm going to put my arrow in. After the blue arrow, I start my products. So I've got zinc nitrate. That is not a metal by itself. It's not a non-metal by itself. So I'm going to need to use my nomenclature rules. So I'm going to crisscross my charges. The charge on zinc, remember he's one of the ones that we circled in the transition metals. Zinc is Zn, and he is always 2+. Nitrate, it's the same as it was before, as NO3. It has a 1- charge. So I'm going to cross my charges. The 2 from zinc is going to come down over here. The 1 from nitrate is going to come down over here. I don't write ones, so we're going to get rid of the 1. So this would be Zn parentheses NO3 parentheses 2. Then I have a plus sign. So next thing, zinc, nitrate, and, so plus, solid lead metal. Now here I've got a metal by itself, so I'm just going to put, and I'm running out of room, the symbol for the metal, PB. Now, this is not done, because we need to balance it. All right, so I'm going to rewrite it just a little bit smaller. I've got zinc solid plus Pb NO32 yields ZnNO32 plus Pb. All right, so I've got zinc, lead, and then nitrate, NO3. On the left, I have 1 zinc, 1 lead, and 2 nitrates. On the right, I have 1 zinc, 1 lead, and 2 nitrates. So this guy's actually already balanced. So this would be my final answer. Okay? Now notice, it's a lot of work, guys. These problems are going to take a long time to do. Okay? So you really have to kind of pace yourself and not get frustrated. You just got to take it one little piece at a time. And the best way to start is to go through and just read the problem and circle your products, circle your reactants, put your plus symbols, put your arrow, figure out where all of that stuff is going to go before you try to do this part down here. All right? So let's go ahead and try another one. Alright, so we have chlorine gas is bubbled through a solution of aluminum bromide to produce aluminum chloride and liquid bromine. So let's start at the beginning. Chlorine gas is bubbled through. So that's going to be a plus because we're mixing two things here. Chlorine gas is being mixed with aluminum bromide. So bubbled through, that's a plus. Then we have aluminum chloride and liquid bromine, so we're going to put a plus there. We have the words to produce right here, so that's going to be my arrow, to produce. Let's look for our reactants. Let's do our reactants in green. Okay, so on the left of the arrow we have chlorine gas and aluminum bromide. On the right of the arrow we have aluminum chloride and bromine. Alright, so let's start by writing our equation. We have chlorine gas. First we need to decide, is that a metal or a nonmetal? So we're going to look at our periodic table. Chlorine is over here. Not only is he a nonmetal, but he is one of the 7 that makes a 7. Okay? So because he's one of the 7 that makes a 7, he's going to be Cl2. Okay? Because remember, the 7 that make a 7 are always going to be diatomic. So he's going to be Cl2. Then we have is bubbled through, so there's our plus. And we have aluminum bromide. Okay, aluminum is Al, and it's one of the transition metals that you circled as always having a constant charge of 3+. Bromide, IDE, means we're talking about bromine, the element, so Br. And he's in group 17, so he has a 1- charge. So we are going to, again, crisscross our charges, so the 3 from aluminum is going to come over to the bromine. The 1 from the bromine is going to come to the aluminum, but we don't write 1, so get rid of your 1. So it would just be AlBr3. Then we have our to produce, so that's going to be our blue arrow. Okay, to produce. And then we have aluminum chloride as our first product, and again we need to crisscross charges. We have aluminum and chloride, IDE, so it's going to just be Cl. Aluminum, we know, has a 3+ charge. Chlorine is group 17, so he's 1-. So we're going to cross those charges. The 3 from aluminum comes down here. The 1 from chlorine comes down here. We don't write 1s. So just be AlCl3. Then we have our and, so that's a plus. Liquid bromine. We got to figure that out. Okay, bromine, he's right here. So not only is he a nonmetal, he's another one of our 7 that make a 7. So he's going to be Br2. So there's my equation. Now I've got to balance it. So I've got Cl, I've got Al, and I've got Br. Okay, on the left I have 2 chlorine, 1 aluminum, and 3 bromines. On the right I have 3 chlorines, 1 aluminum, and 2 bromines. Alright, so we've got a 3-2 problem again. This is similar to the one that we did yesterday on the word equations, or the balancing equations worksheet that we were working on in class. Okay, so what we're going to do, let's just start with chlorine because it doesn't really matter which one we start with. We need to go to the lowest common multiple, which for 2 and 3 is going to be 6. So on the left, how do I make that 2 a 6? I multiply it by 3. So that makes that a 6. On the right, how do I make a 3 a 6, I multiply it by 2, that's going to change that to 6, but that also, remember, is going to affect my aluminum. It's going to change my aluminum to a 2. So let's fix that aluminum real quick. I've got 2 on the right, 1 on the left. So I'm going to put a 2 in front of aluminum. That's also going to affect the bromine. So 2 times 3 bromine is 6 bromine. So, excuse me. So I've got 6 bromine on the left and 2 on the right. So to make a 2 a 6, I'm going to put a 3 in front of it, and there we go. So there is my balanced word equation. We're going to spend all day of class tomorrow practicing this, you guys, so don't freak out. I know this looks overwhelming at first, but we're going to practice it tomorrow one piece at a time until we get it. Thanks for watching the video, guys. Have a great night.